Okay, so we are looking at the rest of section 4.3. There's a few more items that we need to talk about. If you grab your calculators, we're going to use our calculators to evaluate some trig functions. Can I have everyone have a seat, please? Okay, so for the first one, we are going to evaluate on our calculator, as soon as mine loads here. Here we go. Okay, so for this one, we want the secant of 5 degrees, 40 minutes, 12 seconds. So on our calculator, we're going to go to a calculator page or scratch pad, and we're going to go to the trig button, and notice there's an option for secant, and we wanted, was it 5 degrees? I pushed the little question mark button to get my degree symbol, and then I needed, it was 40 minutes and 12 seconds. So I need 40, again, I have to go to the question mark button to get the minutes, and then 12, and then for this one you have to do the minute button twice. So minute button, minute button. All right, at this point I want my decimal answer for this, so I end up getting 1.00492. Do you agree?
Yep.
Okay, and likewise, you could do cosecant of 34 degrees, 30 minutes, 36 seconds, but I think you get the idea, right?
Yep.
Okay, so let's move on, because the rest of this section all involves, application problems for right triangle trig. But we do have to have a little clarification of our meanings of angle of elevation and angle of depression. In these stories, these word problems, sometimes they will ask you to calculate the angle of elevation or the angle of depression. Both of them always have a horizontal piece to it. So an angle of elevation is going to be from the horizontal up. So that would be, like this angle of elevation here. Angle of depression is always going to be from the horizontal down to whatever you're looking at. So this would be an angle of depression. All right, always from the horizontal up or horizontal down. All right. So let's take a look at, I want to skip that example. Let's take a look at this one. A biologist wants to know the width, W, of a river. Here's our river here. This is going to be the width this way from A to C. So she starts out at point A, and then she walks downstream 70 feet until she gets to point B, and then she sights to point C, which was directly across the river from where she started. And she finds out that that angle there, she can use some measurements to figure out that that angle is 54 degrees. All right, so how wide is the river?
I see, so we find
Well, in this case, we do want to use SOHCAHTOA. So in order to do that, what would we use to set this up?
tangent.
Tangent? Tangent of what?
54.
54 degrees equals?
W over 70.
Why did you choose tangent?
Because tangent is opposite, adjacent.
All right, opposite over adjacent. We wanted to find W and we knew 70. So we knew the adjacent side and we wanted to find the opposite side. So calculators, please. You're going to do 70 times the tangent of 54 degrees. And you're going to end up getting what? What is it?
47.166.
So W equals 47.166. Do people agree with that? What units would we be talking about here?
Degrees.
47 degrees?
Wait, oh, we're finding width. It's feet.
Yeah.
Feet? Are we okay with it?
Yeah.
Wait.
Yeah.
You did not?
No.
Yeah. I'm just trusting you guys. Let's see. So
The degrees.
I want 70.
She forgot the degrees.
Oh, see, that makes a big difference. Remember, we were agreeing that we're always in radian mode, but that means that we do need to override it. 54, and we need to have that degree symbol. All right, and I'm getting 96.3 approximately. Are we okay with this? All right, so this should be 96.3 feet. Questions on this?
Yeah.
Jacob?
Why couldn't we just take the sine of 54 degrees?
Well, the sine is the opposite over the hypotenuse, and we don't know the hypotenuse. The hypotenuse is this distance.
Yeah.
Right? We don't know that, so we're going to use the piece of information we do know, which was the adjacent side. So we want to use either cosine, but that's going to find that distance from B to C, and that we don't want, right?
Couldn't we plug into the calculator sine of 54 degrees?
Okay, but sine of 54 degrees is going to be equal to W over some other unknown length, that we call it Y if you want. That's this length, right? Which we don't know. Okay? All right, let's take a look at this example. A ramp 17.5 feet in length rises to a loading platform that is 3.5 feet off the ground. Find the angle theta that the ramp makes with the ground. This is another case for SOHCAHTOA. What would we use? Sine, cosine, or tangent in this case?
Cosine.
Cosine, do people agree?
Sine.
I hear cosine, I hear sine.
Oh, it's sine, yeah.
Sine, because sine is opposite over hypotenuse. This is the opposite side, this is the hypotenuse. So can we say sine of theta equals 3.5 over 17.5? Is this okay?
Yeah.
All right. And so you're going to use your calculator to do this. And can you give me a decimal for 3.5 over 17.5? 0.2? Is that what that's what I'm getting? Okay, but let's talk about this for a minute. So we want, this is the sine of theta. It is equal to 0.2. So we are looking for some angle whose sine value is 0.2. Agreed? The way to do that is to find the inverse sine. All right? So we really want to find inverse sine of 0.2. Sine inverse of 0.2 is going to give us the angle that we're looking for. So we grab our calculator and we're going to do, let's see, we're going to go to trig button, and this time we want sine inverse, which is this button right here, and of 0.2, and I'm getting 0.2014.
Wait, why did we have to, can you explain that again, why we had to use the inverse of sine?
Yeah. If I know that the sine of pi over 6, sine of pi over 6 is like over here, order pair square root of 3 over 2 comma 1/2, right? So the sine of pi over 6 is going to be 1/2. Agreed? So the sine inverse of 1/2 is going to be square root of 3 over 2, right? We're saying, this is saying what angle will give me a sine value of 1/2, and the answer is square root of 3 over 2. I'm sorry, that's not what I want to say. I take it all back, now that I've thoroughly confused you. The sine inverse of 1/2 is equal to pi over 6, because this is saying what angle gives me a sine value of 1/2, pi over 6 would be the angle. We're going to talk more about inverse trig functions in section 4.7, which we'll get to in January, but for right now, all I need you to be able to do is say, if I'm looking at a question like this, where instead of trying to find the sine of 0.2 or the sine of 54 degrees, I'm trying to find the angle that gives me a sine of 0.2, that's when I need to grab the calculator and use the sine inverse button. That's all you need to know for this section as far as inverses are concerned. There's much more that we'll be doing, but that's all you need to do in this particular case. So when we do this on our calculator, I get 0.201. What units is this?
Radians.
Degrees.
No, radians.
I think our calculator, we agreed, our calculators are in radians, right? So this is 0.201 radians. So how do I convert that to degrees? I get theta is equal to 0.201, is that right? 0.201? Yeah, 0.201 radians, and so how do I convert that to degrees? Augie?
You would go 0.201, like you do the picket fence thing, so
Picket fence.
you would multiply it by 180 over pi.
All right, so I'm just going to say times 180 divided by pi, and I am getting 11.5-ish, 11.54. Do people agree with this? So my answer here is 11.54 degrees. Because, Alex,
Is the question or like solely in degrees then?
pardon me?
Question before, is that just in degrees?
This question,
No, one before.
the one before, the biology problem, the river,
Yes,
this one?
that's all in degrees, right? Nothing grading.
Yes, because we were given this angle theta in terms of degrees. Yeah, Jacob?
So, if you think about it, wouldn't it not make sense for it to be 0.2 degrees because that's practically nothing? Like if that was 0.2 degrees instead of radians.
It's not it's 0.2 radians.
Right, but like if it was degrees, it'd be like an major.
Sure, right. That would be very, very small. Yeah, less than 1 degree. Okay, let's see what else. I have another example. No, that's it. Let me make up one real fast for us. Let's say I had theta here, and let's say this side is, let's go with 5, and let's say this side is 4. Can you tell me what's this angle theta in this case? How would you go about setting this up? Hannah? Cosine of theta?
Yeah.
Equals what? 4. Does everybody see where Hannah's getting this from?
Yes.
Okay, and if cosine of theta is equal to 4/5, then theta has to be cosine inverse of 4/5. This is really saying what angle has a cosine of 4/5 is what this is saying, right? And you use your calculator, and you end up getting what?
0.643.
And what units is that?
Radians.
Trig, cosine inverse, 4/5. Oh, my CAS will do that for me, but I don't really want it to. Let's see. Did you get 0.6433? What units? Radians. So if I want to convert that, I'm going to say times 180 divided by pi. Did you get 36.9, something like that? 36.9, what units?
Degrees.
Degrees. So here's my question for you. 36.9 degrees is what I get here. Equals 36.9 degrees. Now really, this is a lovely triangle here, but maybe it's really, that was more like 5. Come on. Work with me. So let's say I had that triangle, but let's say I want to compare that to this slightly bigger triangle where this is 12 and this is 15. Can you find this angle theta here?
Wouldn't it still be the same?
Why would it be the same?
Because the triangles are proportionally the same to each other. You just multiply all the sides by 3.
Very similar.
Bailey?
You divide 12 by 15, just reduces to 4.
All right, so both explanations are fine. So here, if I wanted to find the cosine of theta is going to be adjacent over hypotenuse, so 12 over 15. The 12 over 15 is still going to reduce to 4/5, correct? Okay, and so we're going to end up getting the same answer. So the idea is the trig functions in a right triangle are always going to be the same if the sides are proportional, right?
That's probably, I think it's a theorem in geometry, right?
What
It's
is?
like the side lengths are the same in a right triangle and they have the same angle measurement.
An angle measures are going to be congruent, yes. Are we okay with this? All good explanations for this. Okay, so let's do this while I'm composing my thoughts about your homework. Can I have everybody come up and get one of these? This is a 4-1 gift, and one of these, this is a 4-2 gift. And